Hello, very good evening, guys. Welcome to BYJU'S exam prep. Very good evening, all of you. I hope everyone is good, fine. Good evening, good evening. Okay, so today we're gonna practice the previous year question, the last 4 years of previous question of the engineering mechanics. Hello, Akshay. Good evening, good evening. How are you all? All good, all perfect, all right. Please do let me know अगर कोई audio and video पे कोई issue है या doubt है, you can tell me in the comment section, or else we can start off today's session of engineering mechanics. Okay, yes, second, yeah. Good evening, very good evening, all of you. All right, Akshay. Okay, Akshay. Actually, I one of my friends' name was Akshay, so wahi se I used to call it like Akshay only. Okay, it's Akshay. Okay. Good evening, good evening. Fine. So, if I talk about today's session, if from the last 4 years there were like 22 questions, so we'll be taking all the solutions for all the 22 questions. But first, before starting the session, I would recommend you please take out a pen and paper so that you can practice along with me. I'll be giving you the PDF just like for the last 3 sessions. I've been constantly giving you for the heat transfer, theory of machine, and industrial engineering. I give you the PDF. You have downloaded also, I think, and today also I'll be giving you the PDF of this session also. The handwritten PDF will be shared. So for that you have to join my Telegram channel, whose link is there on the screen. That is this one, the Mechanical by Suraj. Okay, fine. All right. 1 second. Okay. All right. So I hope so everyone is connected with me on my Telegram channel, where I will be constantly sharing all the PDFs for your practice for any of the examination. And hello Said, hello, good evening, good evening. And those who had not yet downloaded our app, there's a link at the bottom of every video. You can click on that. Okay, in front of my name there will be a link, something like this. You can click on this and you can avail the free classes which is happening on our app in morning also, in evening also. Lot many practice session is being covered from all the subjects, not only 3 to 4 subjects, all the subjects being covered from the different faculties. So I think that is a good thing if you are actually downloading the app for more interactive interface. Along with that, as you know that our BYJU'S exam prep has open up the mega mock test, all India mega mock test, where you'll be having the subject wise test also, and your full length mock test. Full length mock test will be from 16th of December to 3rd of Feb. Subject wise test will be starting from 14th of October and will be commencing till 2nd of December. Okay, so this is the entire list. So I hope so everyone has registered yourself for more practice of the question, and in our app we'll be having lot many interface. So this is my app class schedule, just like I told you. Today's 13, that is Friday, we'll be having 8 p.m. class, the friction and its application at 8 p.m. After this session, we'll be meeting there also. Tomorrow we'll be having the kinetics of rigid body, and Monday we'll be having the trusses. So this is the complete list of classes we're having on the app. Okay. Fine. So let's begin with the first question on the screen from the 2020 engineering mechanics paper set 1 2 marks. So let us see who's going to give me the answer for this. Okay, let me check. Yes, a circular disc of radius r is confirmed to roll without slipping at point P and Q. So there is no rolling, there is no slipping at point P and Q. This is a pure rolling case. If the plates have a velocity as shown in the figure, that is V and 2V, then which is the following is giving us the magnitude of the angular velocity of the disc? Chaliye. Which of the following option gives us the angular velocity of the disc? Chaliye quickly. Option A, B, C or D. A very easy question, but for this you need to have a proper understanding. First of all, tell me the eye center will be located at the center of this particular disc, or near to P or near to Q. Where will be the instantaneous center be located? Exactly at the center of the disk, near to P, near to Q, or at point P or at point Q? Yes, Ashay. Yes, site. Near to P. Okay. Absolutely correct. Because if you see at point P, the velocity is V, at point Q, the velocity is 2V. And we know that what is V? V is equal to R into omega. As both the bodies are rotating with the same angular velocity, but the velocities are different, so can we say the radial distance will be more? So if I say over here, if I draw a straight line, the eye center will be definitely located on this particular line. But let us suppose it is located over here. Okay, this is the center O, and I'm assuming this distance as x. And they are talking about what is the omega value. What is the omega value? Okay, so try this one. First of all, we need to calculate the value of x. Once you get the value of x, you can use any one of the equation, because Vp is equal to x into omega. Vq will be equal to r plus x into omega. Okay, or 2r minus x into omega, both are giving the same results. So divide this, you can get the value of x. Right, once you get the value of x, you can place in one of the equation, because this is equal to v, this is equal to 2v. Take the ratio, take this ratio, we can say v by 2v is equal to, anyone who has calculated, this is the eye center, let us suppose this is x, this is the center O, so this is equal to x into omega divided by r, oh, this is 2r minus x. This is 2r minus x, right? 2r minus x, because this distance will be 2r minus x. 2r minus x. Okay. So 2r minus x will be this one. So can you tell me what is the value of x? Omega get cancelled out, v get cancelled out. So this is equal to 2x is equal to 2r minus x. So x will be equal to 2r by 3. X equal to 2r by 3. You can place in any one of the equation and get the value of omega. Let us suppose I am placing in Vp. Vp is equal to V is equal to r into omega, or x into omega. X into omega. So x is equal to 2r by 3 into omega. R omega is equal to this one. Okay. Option C. Very good. So 3v by r. Okay. Fine. So your omega will be equal to 3v by 2r. 3v by 2r is answer. 3v by 2r, option C is the correct answer. Very good, Ashay. Very good. 3v by 2r, option C is the correct answer. Done. There are a lot many questions. We have to cover each and everything. So I hope so now this is quite clear. Option C, that is 3v by 2r, you are getting by simple for calculation. Okay. Done. Question number 2, can we proceed? Yes. Okay. Chale, next question, question number 2 on the screen. The attempt is made to pull a roller of weight W over a curve that is stepped by applying horizontal force F. We are applying a horizontal force F, right? The coefficient of static friction between the roller and the ground, including the edge of the step, is mu. So the mu is the coefficient of friction. Identify the correct free body diagram of the roller when the roller is just about to climb over the step. So which of the following is giving us the correct free body diagram of that corresponding problem? Yes, everyone, tell me in the comment section. Which of the following is giving us the correct free body diagram for this particular combination? Is it option A, or is it option B, or option C, or option D? And the body is about to slide. The body is just about, not slide, just about to topple. Okay. So when the body is just about to topple, we won't be having any friction between the horizontal surface, right? So can I say option B is the first option which we can directly eliminate? Option B is the first option which we can directly eliminate. Okay. Fine. Now, whenever the body is about to topple, right, the body is not, if you see the question, they're saying that the body is, the attempt is made to pull a roller to curb over a step by applying horizontal force. It is not being toppled, right? We are just about to topple. So if I say the free body diagram, there will be three forces acting on this body. We'll be having a weight of the body, will be having one normal reaction, and that will be passing through this. There will be total 3 forces acting, right? And the body is about to roll, it's not, or about to topple, right? The friction at the point, at this point won't be present, because if the friction is present, then we'll be having an unbalanced force. So definitely option D is also not possible. Now we are left out with A and C. Now we are left out with option A and C, right? If you try to visualize, whenever we are talking about the free body diagram, we are only drawing the body, we are not drawing the surfaces. So A is also not possible. So option C is the correct answer. Even though if the surface was not present at A, then A and C both would have been correct. Whenever you're drawing the free body diagram, we are only drawing the body and the number of forces acting. We are not drawing the surfaces. Clear hai? Option C is the final correct answer. Clear, Ashay? Done? Because students do have we can say problem in drawing the free body diagram. I hope so. Now this is quite clear. Option C is the final correct answer. Can we go to the next question? Question number 3. This was a question asked in 2020. Okay, so tell me one thing. When the body is about to topple, let me take a simple example. When the body is about to topple at this point, this is that diagram, right? This is that diagram. So when the body is about to topple, then what will happen? The body is at equilibrium condition. If I say limiting condition means equilibrium condition. So when the body is in equilibrium condition, can we say that the total force acting on the body will be equal to 0? Yes. So this is the normal force, this is the weight, this is the normal reaction, this is your normal reaction, that is R, and this is the force F, and this will be, all will be the concurrent force, all should be concurrent force. Now let us assume that if you are having a friction over here, can we say the total force acting on this body will not be equal to 0? That means the body is not in equilibrium, even though we are saying the body is an impending motion. Is this clear? Understood? Clear, Ashay? Right? Why we have not taken? Because that is a basic conceptual understanding from the friction topic, right? Fine. Chaliye, next question. This is a 1 mark question, I think. In yesterday's app class also we have solved this problem. This is a previous year question, 2021, I think they have asked. A beam of negligible mass is hinged at support P and has a roller support at point Q. You have to tell me, if a point load of 1200 Newton is applied at point R, what is the magnitude of the reaction force at point Q? But at point Q, what is the magnitude of the reaction force? So whenever we need to calculate the reaction forces, we always need to take the moment about that point where the number of unknown forces are more. So it is clearly visualized that at point Q, we can take the moment. At point P, we can take the moment and make it equal to 0. Right? At this point, we'll be having one reaction force RQ, because this is a roller support. So I can say 1200 into 5 is equal to RQ into 4. So RQ is equal to how much? 1500. I think this question was solved yesterday also. Okay, fine. So RQ is equal to 1500 Newton. Very easy. Hardly took 30 seconds to solve it. All right. Clear hai? Understood everyone? Done? Clear hai? The reaction at point Q is equal to your this one. Chaliye, next. Question number 4th on the screen. Two smooth identical spheres of radius 125 mm and weight 100 Newton rest on a horizontal channel having vertical walls. The distance between the vertical walls of the channel is 400 mm. The reaction at point P, at the point of contact between the two spheres, they are asking you what is the reaction in between these two. Let's say this is R1. So what is the reaction R1 they are asking? The value of R1, reaction force in Newton. Quickly, draw the free body diagram. Whenever they are asking you the forces, always draw the free body diagram, then the problem becomes very easy. Okay, let me magnify this diagram. So if I try to join these 2 points, okay, and if I try to draw an angle, let's say this is theta. Okay, so this is, let us suppose A and B. If I try to draw the free body diagram of A, free body diagram of sphere A, right? Free body diagram banate hain. So at point A, we are having, let's say there's one reaction force R2, right, will be having a weight W and one reaction force R1. So this is your R1, right? This is R2 and this is W. Let's say this angle is theta, so this angle is also theta. They're asking you the value of R1, है ना? Reaction between the contact of the two spheres. They're asking you the value of R1, so we can directly say R1, the total vertical force equal to 0. So R1 sine theta is equal to W. Now we need to calculate this value of theta. How we can calculate? Now radius is given, so can we say this total distance equal to 250? R plus R, that is 250. So I can say, and what will be this distance? This is equal to, this is 125, this is 125, this will be equal to 400 minus 250, right? That is equal to 150. Yes, right, 125 on one side, 125 on the other side, total is 400. So 400 minus 250 will be simply equal to 150. So we can say cos theta will be equal to 150 by your 250, that is equal to 3 by 5. If cos theta equal to 3 by 5, I can say sin theta will be equal to 4 by 5, right? 1 minus under root of cos square theta. So we can say R1 is equal to 4 by 5. What is the weight of the block? Weight is equal to 100 Newton. 100. So R1 is equal to 500 by 4. That is 125 Newton. 125 Newton is the correct answer. Yes, 125 Newton is the correct answer. Done? Simple. Okay. Any doubt, please do let me know in the comment section. Whenever you feel any doubt at any point of time, you can tell me. Because questions level from mechanics, that is why I always tell you mechanics, heat transfer, industrial engineering, 3 most easy, most scoring subjects from GATE examination perspective. ठीक है, चलिए next question. Question number 6th. The members carrying zero force, that is zero force member, is shown in the trusses. You have to tell me which of the members are the zero force members. Which of the members are zero force? I think now you are able to see the diagram. Okay. Which of the members are zero force? Now, whenever we need to identify the zero force member, you always need to see a point where 3 forces are acting and 2 forces are collinear and third non-collinear force will be equal to 0. So is there any point or any joint where 3 forces are acting and 2 forces are collinear? Third member will be non-collinear member will be equal to 0 force. Okay, you start from this point. At point D, HD is a zero force member because CD and DE will be equal to 0, will be equal. So DH is equal to 0. At point G, GC equal to 0. At point B, FB equal to 0. So directly we can say HD, GC and FB. 3 members are directly 0. So is there any option we can eliminate? HD is there in all the options, I think. BF is also there. GC is also there. So option D is being eliminated. Option D is being eliminated. Okay. Now, is there any other member where we can say there will be zero force member? Now, if you try to visualize joint E, at joint number E, the roller support is making an angle of 45, and it is clearly visualized that this is 1 and this is 1. So this angle is also 45, right? Because this base is 1 and this height is also 1. So can we say the reaction force will be exactly along the HE line? If the reaction force is along the HE line, can we say all the reaction force will be induced in HE? So DE is also 0 and DE is also equal to CD. So this is equal to 0. So in total we are having 5 members are zero force. This is DE and CD. Okay, DE and CD. D and CD. I think option C is the correct answer. Yes, option C is the final correct answer. Okay, understood? Option C is the final correct answer. That is BF, DH, GC, CD and DE. Okay, done. Chaliye, next question. Very easy. Okay, Question is a plain truss PQRS, where PQ is equal to RS, both are having the length of L, both are having the length of L. PQR is a 90-degree angle. Okay. So they're asking you what is the force in the member PR and RS. PR and RS. What is the force in these two members? PR and RS. FPR and FRS. You have to calculate force in both of these members. Okay. Can anyone who can tell me which of the members will be having a zero force? By looking at the diagram, which of the members will be having zero force? Can you tell me? So that will be helping us. PR, sure. Okay, if you take joint Q, can we say there is no external force being applied? So PQ and QR, these are two zero force member. Can we directly say PQ and QR are the zero force member? Yes. Now I can take joint R. If I try to take the free body diagram of joint R, okay, so I can say at joint R we are having a force F acting right hand side. This is 0. We are having FPR and we are having FRS. All I'm assuming to be the, okay, this angle is 45. We can get the value of FPR, we can get the value of FRS. Simple, calculate and tell me the correct answer. Options are there on the screen. So can we say the total horizontal force equal to 0? So from here F is equal to FPR cos 45. So FPR is equal to cos 45 is 1 upon root 2. So this is root 2F. That is tensile in nature. Positive means it is tensile in nature. Okay. So FPR is root 2. So option B and C is being eliminated. A and D may say एक option will be correct. है ना? चलो. Now let's talk about FRS. Can we say total vertical force equal to 0? So FRS plus FPR sine 45 equal to 0. Okay, so FRS is equal to minus of FPR sine 45. FPR is equal to how much? Root 2F minus of root 2F into 1 upon root 2. So this is minus F. So I can say FRS is equal to the force F, compressive in nature. Compressive in nature. So FRS is equal to F, which is compressive in nature. I think we are getting option D as a correct answer. Okay, option D is the correct answer. Clear? Sai, Ashay? Okay, done. Perfect. Chalo, next question number 8. Okay, we'll be investing more time on those problems where slight difficult concept will be there. Easy questions mein to bhai jaldi answer will be calculating. Okay, next question. A block of negligible mass rests on now please see this statement. Negligible mass rests on a surface that is inclined at an angle of 30 degree to the horizontal plane as shown in the figure. When vertical force of 900 and horizontal force of 750 Newton is being applied and the block is just about to slide, that means impending motion. That means that it's an equilibrium condition. The coefficient of static friction between the block and the surfaces. The value of mu they are asking. Now, first of all, tell me what will be the direction of friction? What will be the direction of friction? Anyone? Who can tell me? Upward or downward? The block is not having any mass. It is negligible mass. Okay, and the body is about to slide. Good evening, good evening. So like काम करते हैं, let us try to draw a perpendicular. Okay, so let me draw it like this. Okay, so or let me draw it like this specifically. Okay, so can I say this is 30, this is 30, so this will be equal to, yes, 750 Downward, very good. 750. Acha, what will be this, cos or sine? This is 30, this 30, this is 750 cos 30, and downward force will be equal to 750 sine 30. Okay, if I try to take, this is 30, this is 60, this angle is 60, so this is equal to downward 900 cos 60, not cos 60, cos 30, cos 30, right? And the downward force will be equal to 900 sine 30. Okay, done. Normal reaction, this is a normal reaction. If you try to visualize, because the body is not having mass, 750 cos 30 magnitude will be definitely more than that of 900 sine 30. So I can surely say the body is about to move upside, that is, this is the frictional force, the downward. Okay, now you can calculate all the forces. Now you can calculate all the forces. The normal reaction will be equal to 900 cos 30 plus 750 sine 30. Solve it. Tell me what's the value of normal reaction. Once you get the value of normal reaction, then we can calculate the friction force. Friction force will be equal to, this will be equal to 750 cos 30 minus 900 sine 30. Let us suppose even if you are taking the friction force to be opposite, कोई दिक्कत नहीं, आपका F का value negative आएगा. That simply means that the assumed direction is wrong. ठीक है? You don't have to worry about the direction of friction force. Solve it. What's the normal reaction force we are getting? Mani, Raghavan, Ashay. 1154.42. Very good. 1154.42 Newton. And what about the frictional force? What about the friction force? 750 cos 30 sine 30 is 1 by 2, 450. So it is equal to 3 by 2 है ना, 375 root 3 minus 450, 199.51 Newton. Okay, and we know that mu is equal to F by N. So what's the value that we are getting? Please tell me in the comment section. Round off to 2 decimal, and what is the final value you're getting? Yes, 0.173. Are we getting this one? 0.173, and they are saying round off to 2 decimals, so 0.17 is the final correct answer. 0.17 is the final correct answer. Okay, Raghavan, 5.7 mu won't be greater than 1, right? 5.7 कैसे आ रहा है? I think you have taken the opposite of that. F is equal to mu n, na? I think you have taken 1 by mu value. Okay, done. Clear, everyone? Next question. Any doubt? Please tell me. No doubt? Chaliye, very good, very good. Chalo, question number 10th on the screen. Okay, question is very interesting. Try to read out the statement. A 2 kg block is shown in figure. It's a top view. This is the top view they have given. This is the top view which they have given. Rest on a smooth horizontal surface, is attached to a massless elastic cord. This is the elastic cord. Okay. Now, having a stiffness of 5 Newton per meter, it is hinged at point O, initially unstretched and remains elastic. The block is given a velocity of 15 meters per second in the perpendicular to the cord. Okay. The magnitude of the velocity of the block at an instant when the cord is stretched by a distance of 0.4 meter. Chaliye, try this. Simple hai. Energy conservation we need to apply. Initial kinetic energy is equal to final total energy, that is kinetic plus potential energy of the elastic cord. Initially it is unstretched, so there is no potential energy at the initial condition, and entire system is moving on a horizontal surface. There is no potential energy due to the height. Okay, so apply the conservation of energy. Applying energy conservation. I can say the total kinetic energy or total energy initial, that is kinetic energy at the initial plus potential energy at the initial position, will be equal to the kinetic energy at the final condition plus potential energy at the final condition. This is equal to 0 because the initial spring is unstretched. Velocity is your this one. This half into m into vi square. Okay, very good. And half into m into vf square plus half into k into x square. I think they are asking you the velocity. Vf nikalna hai. Chaliye, simple. Half get cancelled. Mass is 2 kg. 2 into initial velocity is 1.5 whole square is equal to 2 into vf square, right? K value is Newton per meter. This is 0.4. Solve it and tell me what's the value. Vf value. Only calculation part is left out in meter per second. What is the final velocity that we are having? Anyone? 1.36. Sapna is getting 1.36. Anyone else? 1.36 meter per second. I think that is the correct answer. Round off to 2 decimals. Option A. Option A is the correct answer. Clear? Are we getting option A? 1.6 money. 1.6 is आपसे option C हो रहा है आपका. देखिए check कीजिए. I think it should be 1.36. This is the relation. Solve it. Use calculator and tell me the final result. Done. 1.36. Very good, Ashay. Very good. Okay, perfect. 1.36. Now everyone is agreeing with this. Anyone having any other value? Please tell me. Chaliye, very good, very good. Chaliye, next question. Let us try to understand this. Question is very interesting. This is the kinetics of rigid body. Okay. Wheels of axle system lying on a horizontal surface is shown in the figure. So we are having a axle, right? This is the side view that you are seeing. This is the side view, right? And that is a front view. There are two axles, just like we are having your train. Train mein yahi hota hai, a rigid rod and two wheels we are using. Okay. Now they are saying that each wheel has a diameter of 0.8 meter and mass of 1 kg. Assume that the mass of the wheel is concentrated at the rim. So it's basically not a disc, it's a rim. Neglect the mass of the spokes. The diameter of the axle is 0.2 meter and its mass is 1.5 kg. Neglect the moment of inertia of the axle. Assume G value. Okay. An effort of 10 Newton is applied on the axle in the horizontal direction shown at the mid of the span of the axle. Assume the wheels on the horizontal surface without slip. Acceleration of the wheel axle in the horizontal direction. Okay, you have to tell me what is the acceleration of this particular wheel. What is the acceleration of this particular wheel? Chaliye, try कीजिए. First of all, tell me what is the mass of the wheel? Mass of the wheel is 1 kg, right? So can we say the mass of the total mass of the wheel? The total mass of wheel is equal to 2 into 1, that is 2 kgs, and mass of axle is given how much? 1.5 kg. Okay, so can we say what is the total mass of the system? The mass of the system will be equal to 3.5 kg. This is the total mass of the entire, because I'll be taking the entire system to be 1 and I'll be doing the analysis. Okay, so now if I try to apply a simple concept, over here we'll be having one friction force, right? This is the force that we are applying. Okay, and the friction will be applied at both the surface. दो friction force होगा. So can we say the total horizontal force that is equal to how much? 10 minus 2f, है ना? It will be 10 minus 2f, 1f over here and 1f over here. So 10 minus 2 is equal to mass into acceleration. Okay, fine. Mass is 3.5. So 10 minus 2f is equal to 3.5 into r into alpha. Okay, so this is 10 minus 2f is equal to, what is the value of r? Radius is equal to 0.4. So 3.5 into 0.4 into alpha. So 10 minus 2f is equal to 3.5 into 0.4. 2.4, that is 1.4 alpha. Okay, right? Let us suppose this is equation number 1. Okay, let us suppose this is equation 1. Now, once we have calculated the force calculation. Now let us try to calculate in the torque perspective. So can we say the total torque will be equal to I into alpha? What is the total torque? Now the total torque will be equal to F, this one. This is 10 Newton, this is F, so we can say this is minus, because this is trying to rotate in the, because the body is trying to move in this direction. So F 10 into 0.1, 10 into 0.1, right? Okay, 10 into 0.1, and due to this we'll be having F into R, okay, plus F into 0.4 is equal to the moment of inertia, that is mr square into alpha, okay, mr square into 1, and that too we are having 2. Yes, okay, mr square into alpha. Chaliye, let's try to calculate. So this is minus 1 plus 0.4 F is equal to 2 into mass is how much, 3.5 into R value is 0.4 square into alpha. Can you tell me this value? Anyone? 3.5 into 0.4 square into 2. This is 1.12. 1.12 alpha minus 1 plus 0.4 F. So there are two equations we are getting. Yes. One second, let me check. I think they have given the moment of inertia as sir, we should consider the moment of the axis separate. No, we have already considered the total mass, right? Okay, is there given any moment of inertia is they have taken that the neglect the moment of inertia of the axle, they have clearly mentioned. Okay, you have to only consider the moment of inertia of the rim. Clear? Fine. 0.4 square into 2. Okay, mass is 1 kg. Now this is the mass of the rim. You have to take over here, they have clearly mentioned that the mass will be equal to only of that of the rim, right? Because they are saying that moment of inertia of the axle need to be eliminated. So mass will be 2 kg, that is 1 into 2 into 0.4. Now what is the value? 4 square into 2. This is 0.32, right? 0.32. Yes. Exactly, Ashay. Because they have mentioned that the moment of inertia of the axle need to be neglected. So that is the reason we are only taking the moment of inertia of the rim. So two equation, you have to solve it and get the value of alpha. You have to solve it and get the value of alpha. Okay, fine. Clear? Chaliye. You have to solve in the two equation. 10 minus 2f is equal to 1.4 alpha. This is minus 1 plus 0.4 f is equal to 0.32 alpha. Solve it and tell me what is the value of f you are getting and what's the value of alpha you are getting. वैसे तो मैं alpha से मतलब है. Okay, चलिए. Okay, done. So F value is somewhere around 2.61 Newton, है ना? और alpha is somewhere around 3.409 radian per second square. ठीक है? Okay, clear? Alpha निकल गया. If alpha is calculated, we can get the value of acceleration. Acceleration of the center of mass is equal to r into alpha. R is 0.4. Alpha is 3.409. So this is somewhere around कितना है? 1.3636. Are we getting this one? 1.3636 meter per second square, and I think they are saying that round off to 2 decimals, so we can say 1.36 meter per second square. This is the value of acceleration. Okay, this is the value of acceleration that we are getting. Done. Interesting question था. 2021 का क्वेश्चन था, आई थिंक दिस वाज अ क्वेश्चन फ्रॉम 2021 गेट पेपर, ऑलराइट। बट इसमें देखो ये वन थिंग यू हैव टू अंडरस्टैंड इज ऑलवेज रीड द क्वेश्चन एप्रोप्रिएटली। बहुत सारे चीजें यहाँ बोलते हैं, है ना, सीली मेंशन दैट यू हैव टू नेगलेक्ट मोमेंट ऑफ इनर्शिया, इट्स अ रिम, नॉर्मली वी आर हैविंग अ टेंडेंसी दैट हम लोग उसको डिस्क लेके सॉल्व करते हैं, अल्टीमेटली गेटिंग द रॉन्ग वैल्यू। ओके, सो ट्राई टू रीड द क्वेश्चन केयरफुली और आराम से क्वेश्चन करेंगे तो कोई दिक्कत नहीं है। चलिए नेक्स्ट क्वेश्चन, वेरी इजी वन। ओके, a rigid block of mass m1 having 10 kg mass is moving with a velocity of 2 meter per second strikes a stationary block having a mass m2 that is 30 kg. After traveling 1 meter along the frictionless horizontal surface, I showed the figure. This is frictionless. This is frictionless. Okay, right. So they are saying that two mass stick together and jointly moves further distance of point together along the same frictionless surface before they touch the massless buffer that is connected to the rigid vertical wall by means of linear spring. Case difference given. What is the maximum deflection in the spring? Very easy question. Energy balance. Your energy conservation लगाइए. Okay, चलिए. The entire surface is frictionless, right? So first of all, tell me what will be the velocity with which the combined mass will be hitting the spring. क्योंकि उन्होंने बोला है the two masses will be sticked together, है ना. अगर वो stick together है, so we can apply the conservation of momentum, है ना. We can apply the conservation of linear momentum. So m1 v naught plus m2 v0, this is basically 0, is equal to m1 plus m2 into v. Okay, mass 1 is 10 kg, moving with a velocity of कितना 2 meter per second, is equal to 10 plus 30 into v. v कितना आ रहा है? v is equal to 20 by 40, 1 by 2, 1 by 2, 20 by 40, that is 1 by 2 meter per second, half. Okay, so this combined mass is now moving with a velocity of half meter per second, and it is hitting the spring having a stiffness of कितना 10 to power 5 Newton meter. So they're asking you what is the maximum deflection of the spring. So can we say entire kinetic energy will be converted into the potential energy of the spring? तभी तो maximum deflection होगा, मतलब velocity is equal to 0. Can we say if you apply the energy conservation, the entire kinetic energy will be converted into the potential energy of the spring, that is half into m1 plus m2 into v square is equal to half into k into x square. चलिए, you have to tell me the answer in centimeter. सेंटीमीटर में आंसर बताएंगे आप लोग. So half get cancelled out, m1 plus m2. m1 कितना था? 10 and 30. m1 is 10, m2 is 30. So this is 40 into 1 by 2 whole square is equal to 10 to the power 5 into x square. So x is equal to how much value? What is the value of x? 4. This is 10, 10 to the power 4 to the power minus 2. Are we getting 10 to the power minus 2 meter? That is equal to 1 centimeter. है ना? भाई देखो ना, 1 by 4 into 40, that is equal to 10. So it will be 10 to the power minus 4. Root of this 10 to the power minus 2. है ना? 10 to the power minus 2 आ गया तो 1 centimeter is the correct answer. So we are getting 1 centimeter as the correct answer. 1 centimeter. कभी कभार विदाउट कैलसी भी सॉल्व करना चाहिए, है ना, बिकॉज इट विल इंक्रीज योर स्पीड, राइट. एग्जैक्टली. चलिए, वेरी गुड, परफेक्ट परफेक्ट. चलिए नेक्स्ट क्वेश्चन. A plane of figure represents a horizontal plane. A thin rigid rod at rest is pivoted without friction about a fixed vertical axis passing through point O. If the mass moment of inertia is equal to 0.21 kg per centimeter square about O. Okay, a point mass of 0.001 kg hits it normal at 200 centimeter per second at a location shown and sticks to it immediately after the impact. What is the angular velocity of the rod? By simple question. Conservation of angular momentum लगाना में, we have to apply the concept of conservation of angular momentum. चलिए, let's see who's going to give me the answer. इसमें क्या हो रहा है? There's a rod, there is a mass, and it is actually sticking. So when it is sticking, the moment of inertia of the entire rod will be changing. पहले the moment of inertia about point O was equal to, according to question, is 0.1 kg centimeter square. Now as it is sticking, so can we see the combined moment of inertia will be I naught plus mr square, that is your 0.001 into 10 square. So this is equal to 0.1 plus 4, 1, 2, 3, है ना? 1, 2, हाँ, 1, 2. This is 0.1, that is 0.2 kg centimeter square. This is the combined moment of inertia. So combined निकल गया बस. Apply the law of conservation of angular momentum and tell me what is the angular velocity just after the impact. 1. Okay. Anyone else? What is the value? Apply conservation of angular momentum. That is sufficient hint आपको मैंने provide कर दिया. So I think that should be easy for you guys to solve. करें? चलो. Applying the conservation of angular momentum. So if I apply the conservation of angular momentum, I can say I0 into omega, है ना? Omega कितना है? Initial is equal to, or MBR, we can say, instead of writing this one, I can say MBR. M into V into R is equal to, because it is having this one angular momentum, right? And that is equal to I0 into omega. That's it. So mass is equal to 0.001, velocity is 200, radius is 10, is equal to 0.2 into, chaliye, what's the value of omega you are getting? 1, 2, 3, 1, 2, 3, 10 radian per second. Are we getting 10 radian per second? Please check. देखो 1, 2, 3, 1, 2, 3, this is equal to 2. So 2 divided by 0.2 is equal to 10. So 10 radian per second is the correct answer. So the angular velocity just after the impact will be equal to 10 radian per second as the correct answer. ठीक है? Done? Clear है? Question number 14th. Done. चलिए next question. Question number 15 on the screen. Acha, before going to question number 15, let me update about one of the information. Dheeraj sir will be coming up live on 18th of October at 7:30, and this is for all the students, those who are targeting now 2025. Okay. Along with that, this Sunday we'll be having the scholarship test also. So you can do register and you can avail the benefits. And this is basically important for 2025 aspirants. Chali, coming to the next problem. A structure along with the loads apply on it is shown on the figure. The self weight of all the members is negligible. All the pin joints are frictionless. AE is a single member. Where is AE? Achha, this one is AE. This is A, this is E. AE is a single member and it is having point D as the C, and BE is a single member. So BE is a single member, right? And that contains point D. The members GI and HF are overlapping rigid members. What is the force in the member CI? Question is, what is the force in the member CI? What is the force in the member CI? Now, whenever you are having questions where you are having slightly complicated diagram, always see the diagram carefully. Is it possible to use method of section? If yes, go for it. right? If you try to visualize, if I take a section from this point, if I take a section like this, I think my problem will be solved, because I'll be taking moment about point E. If I take moment about point E, the problem will be solved. You can eliminate the left hand side, but the problem here is, what will be the height CD? CD is, I think, vertical, है ना? So it's not given, so okay. CD will be vertical only, right? So if I try to take this triangle, this one, if I try to take this triangle, let me use different color, okay. If I try to take this triangle, this one, AC and BD, and this triangle, the smaller one, okay. Can we calculate the height of CD by using the similar triangle concept? Can we calculate the height of CD? Can we say AB by BE is equal to CD by CE, CD by DE, right? AB is equal to 3, B is equal to 4, CD we need to calculate, DE is equal to 2. So from here CD is equal to 1.5. We got this height. Now you can take the method of section and eliminate the left hand side. So we are having three members, this one, and this one. Okay, you eliminate the left hand side, so we can take the moment about point E and make it equal to 0. If you take moment about point P, this force and this force will be cancelling out, only we are left out with FCE. So FCI into this height is now coming out to be 1.5. So this height is 1.5, so this is 1.5, rotating in anti-clockwise, negative sign. We are having two forces, this is 2 Newton, so this is rotating clockwise, 2 into 1.5. This is also clockwise, 4 into, what is this distance? 3 plus 3, that is 6, equal to 0. It's a single one-liner. In single one line, we are able to calculate. So what is FCI? Option A, achha, there is no option, we have to calculate in integer. So FCI is coming out to be 2 into 1.5 plus 4 into 6 divided by 1.5. Okay. So tell me, what is the force in the member FCI? This is in, I think, kilonewton. Nearest value, nearest integer, you can tell me. So 3 plus 24 divided by 1.5. This is coming out to be 18 kilonewton. Yes, 18. Very good, Ashay. Very good. We are getting this to be 18 kilonewton. So I think 18 kilonewton is the correct answer. All right. 18 kilonewton is the final correct answer to this question. Done. Can we go to the next one? Question number 16 on the screen. This is also interesting, right? And try to read the question carefully, because in the question itself, lot many information is being provided. Two rigid massless rods PR and RQ are joined at a frictionless spin at joint R and it's resting on the ground P and Q respectively, as shown in the figure. A vertical force F is acting on point R. When the included angle is less than 90, the rod remains in static condition. That means when the angle is less than 90 degree, the rod is in static condition, right? Now, when you are making this angle to be equal to 90 degree, then we are having the impending condition. What is impending condition? Impending means the body is about to slide. That means impending slip occurs simultaneously at point P and at Q. Then what is the ratio of coefficient friction at point Q to P? That is mu Q by mu P. What is this value? Let us assume this angle is equal to alpha and this angle equal to beta. Okay. Can we calculate the value of tan alpha? Only the value of tan alpha. Alpha value is not required. Tan alpha will be equal to 12 by 5, and tan beta will be equal to 5 by 12. Yes, because we are talking about at theta equal to 90 degree. when theta equal to 90 degree, the motion is impending. So all the calculation will be done when theta equal to 90. Okay, fine. So now let us try to take the joint P. You try to take the joint P and see what are the forces acting and how we can calculate the value of mu P. Okay, chaliye try this one. How we can calculate the value of mu P? Try कीजिए. 0.15, okay. If I take joint P, joint P पे ये वाला force है, देखो, this force that is FPR, है ना, FRP, right? Okay, and because the force is like this, we'll be having friction force in this direction. This will be the normal reaction, right? Okay, and can we say that because the body is in equilibrium, it's an impending motion, the resultant of these two forces will be acting exactly in the direction of this one? This will be the resultant of these two forces, right? And we know that this angle is alpha. I think we have assumed this angle as alpha. This angle is alpha. So this angle will be 90 minus alpha. Yes. If this is 90 minus alpha, guys, so tell me what is tan 90 minus alpha is equal to mu P. Can we write it like this? We know this tan phi is equal to the coefficient of static friction. Here the angle between the normal reaction and the resultant is angle of friction. Here the angle of friction is 90 minus alpha. So we can say tan 90 minus alpha is equal to this one. So this is equal to cot alpha. Okay, this is cot alpha, right? Chalo, coming to the second point, that is Q. At point Q, we're having a force acting, that is RQ, FRQ. This is your normal reaction, and because the body will be trying to slide on the right hand side, the friction will be on the left hand side. This will be the direction of friction. Let me write this point Q over here. Okay, so the resultant force will be acting along the direction of RQ. This is the resultant force, right? This angle is angle of friction. This is beta. This is 90 minus beta. So can I say tan 90 minus beta is equal to mu Q, or cot beta is equal to mu Q, right? We got the two relations. We can now easily calculate the value of mu Q by mu P. So mu Q by mu P is equal to cot Q value का क्या है beta, cot beta by cot alpha, है ना? Fine, P by Q by P, na? Q by P. So this is equal to tan alpha by tan beta. What is tan alpha by tan alpha is equal to 12 by 5. 12 by 5 into tan beta is 5 by 12. So this is 12 by 5. So this is 144 by 25. So tell me what is the nearest value? What is the nearest value? 144 divided by 25. 5.76. 5.76 is the answer. They are saying up to 2 decimal. So 5.76 is the correct answer. 5.76 is the ratio of the coefficient of static friction of Q divided by P. Done? चले आगे. All right, question number 17. Now they are talking about a cylindrical disc having a mass of 1 kg, radius is 0.14, was spinning at a angular velocity of 5 radian per second when it was placed on a flat horizontal surface. Release, refer to this particular diagram. The gravity acts vertically downwards as shown in the figure. The coefficient of friction between the disc and the surface is finite and positive. Disregarding any other dissipation except due to friction between the disc and the surface, the horizontal velocity of the center of the disc when it starts rolling without slipping will be equal to. So actually what has happened is the disc was rotating initially, okay, while it was rolling, and I'm just keeping on the horizontal surface. Okay, so they are asking you what is the horizontal velocity of the center of the disk when it starts rolling without slipping? So initial case में तो slipping होगा ना, when you try to let's suppose there is a disk which is rotating, है ना, तो जैसे we are keeping at the surface will be having some slipping, उसके बाद this will be moving in the forward direction. Okay, so the question is, what will be the angular velocity, what is the velocity of the center of disk when it starts rolling without slip? Question समझ में आया? Here students are committing a simple mistake. They are saying that omega is given, r is given, r into omega करके निकाल देते हैं, है ना? That is wrong. That is absolutely wrong. वो आपको नहीं करना है. क्यों? देखो समझिए. What has happened is this is the horizontal surface. Okay, this is quite interesting. तो पहले ये घूम रहा था. It was rotating. Okay, it was not touching the ground. It was rotating. So when it touched the ground, तो वहां पे तो थोड़ा सा slipping होगा ना. And after that only it will rolling without slip. So let us suppose just we are releasing from when you are keeping on the ground, it is rotating with an angular velocity of omega 0. है ना? Yes, it will be rotating with an angular velocity of omega 0, right? After some point time, like might say microsecond, हो सकता है microsecond, it will be rolling without slip. Okay, let's say this is omega 2. So we need to calculate this omega 2, and omega 2 into r will be equal to the velocity at the center point. How we can calculate? तो इसमें आपका simple, can we apply the conservation of angular momentum? जब कुछ समझ ना आए ना आपको, जब whenever you are having any doubt, कभी भी ऐसा होता है question, go for the conservation of angular momentum. Apply and get the value. Apply the conservation of angular momentum. ये क्वेश्चन बहुत अच्छा था. आई डू रिमेंबर, आई थिंक दिस वाज अ 2022 क्वेश्चन या 2023, दोनों में से कोई है. 2022 का है शायद. उस साल मेनी स्टूडेंट्स दे हैव मार्क्ड आंसर एज r into omega डायरेक्टली. ओमेगा उन्होंने 5 रेडियन पर सेकंड ले लिया, रेडियस इज इक्वल टू 1.5 मल्टीप्लाइड एंड दे गेट द रॉन्ग आंसर. ओके, तो गेट में कभी कभार ऐसा होता है, दे आर आस्किंग गुड लेवल ऑफ क्वेश्चन. चलिए, तो इनिशियल इट विल बी रोटेटिंग विद सम एंगुलर वेलोसिटी ओमेगा. So I0 into omega 0, okay, is equal to IF into omega 2 plus MR into V or MR, okay, because it will be traveling some distance, na, right? So this is moment of inertia. This is a solid disk. This is mr square by 2. I think they are given as solid disk, na? Solid disk, mr square by 2. mr square by 2 into omega 0 is equal to mr square by 2 into omega 2 plus m into r into omega mr square, है ना, mr square omega, mr square omega 2, that 2 omega 2. So this will be equal to how much? This is 2 3 by 2 mr square omega 2 is equal to mr square by 2 into omega 0. So 2 get cancelled out, mr square get cancelled out. So omega 2 is equal to omega 0 by 3. Omega 0 how was omega 0 is equal to your this one 5 radian per second. So this is 5 by 3 radian per second. So now I have calculated the value of the angular velocity जहां से आपका rolling without slip start हो गया. Okay, fine. So V is equal to now R into omega. What is the radii of rotation? That is equal to, I think, 0.15. 0.15 into omega is 5 by 3. So this is equal to 0.25 meter per second. Okay, 0.25 meter per second. Is this clear? इसमें कुछ लोगों ने 5 into 0.15 कर दिया था and they were getting 0.75, which is absolutely wrong. Are you able to understand क्यों हमने वो डायरेक्ट मल्टीप्लाई नहीं किया? ठीक है, हमारे देखो यहाँ पे dissipation is not there, but there is a friction between the disk and the surface, और उस friction की वजह से will be having a loss of omega, and that we are actually able to calculate over here. Okay, clear hai? Understood? It's not 0.75. I do remember, abhi bhi mere ko yaad hai, students were directly multiplying r into omega and they were getting the wrong answer. तो मैं फिर से repeat कर रहा हूँ. This is a very interesting question from the concept of your जनरल प्लेन मोशन या रोलिंग मोशन से. ओके, चलिए नेक्स्ट क्वेश्चन ऑन द स्क्रीन, क्वेश्चन नंबर 18. A square plate is supported in 4 different ways, P to S. There are 4 configurations, P, Q, R, and S. A couple moment C is applied on the plate. Assume all the members to be rigid and massless, and all joints are frictionless. All the supports length of the plate are identical. So you have to tell me which of the square plate will remain in equilibrium in its initial state for which of one or more of the following configuration. This is an MSQ problem. MSQ question. इसमें देखो वो बोला है ना क्वेश्चन में, देखिए disregarding any other dissipation except the friction that due to friction between the disc and the surface. अगर friction नहीं होता ना, then that body would have been rotating at that particular point. वहां slip होता रहता है ना, वहां slip होता रहता. It might be rotating with a constant omega r, मतलब 5 radian per second पे it was constantly rotating, but because of that friction what happens, there is a loss of omega, है ना, fine. But यहाँ पे उन्होंने energy loss नहीं बोला. They have not talked about what is the percentage of loss happening. What happens is once you are touching this, okay, it is converting into a translatory plus a rotational part. हाँ, exactly. देखो उसमें लॉजिक ये है, व्हाट हैज हैपेंड, इनिशिएट वाज रोटेटिंग सम ओनली प्योर रोटेशन, वंस यू आर कीपिंग दिस, अब क्या है आपका रोटेशन इज कन्वर्टेड इनटू ट्रांसलेटरी प्लस रोटेशन. सो डेफिनेटली योर सम अमाउंट ऑफ एनर्जी विल बी ट्रांसफर्ड. पहले प्योर रोटेशन था, अब वी आर हैविंग रोटेशन पर ट्रांसलेटरी, सो सम अमाउंट विल बी गिविंग टू ट्रांसलेटरी, सम अमाउंट ऑफ एनर्जी विल बी गिवन टू रोटेशन, राइट. तो इसी कारण आपको यहाँ पे ओमेगा की वैल्यू में डिक्रीज देखने को मिला, फ्रॉम 5 रेडियन पर सेकंड टू 5/3 रेडियन पर सेकंड. Okay, chalo. Now this is an MSQ problem. This is an MSQ problem. There will be multiple options will be correct. This is the answer, which one or more of the configurations is correct. चलिए पहले देखते हैं ये वाला. Is this particular arrangement in an equilibrium condition? Is this particular arrangement in an equilibrium? चलो देखते हैं. There are 3 forces acting. This is F, F and F. Okay, so this is F, F and F. So is the total force acting on the body equal to 0? Yes sir, can we say, because these are concurrent forces, total force equal to 0, right? But there is one unbalanced couple. देखो यहाँ पे couple भी applied किया है. So can we say the total moment is not equal to 0? That simply means the body is not in equilibrium. Okay, the body is not at all in equilibrium. So option first of all is not the correct answer. Okay, P wala configuration is not in equilibrium. Let us go with the second configuration. F, F, F and F. Okay, 1, 2, 3 and 4. Now here if you see, there are 4 forces acting. The total force is still equal to 0. अभी भी 0 है. F नीचे, F ऊपर, F left, F right. Moment की बात करते हैं. There is an applied moment of C. Due to this, all the forces will be having an opposite moment like this. So here can we say the total moment will be equal to 0. Both the condition is being satisfied. So I can say this is an equilibrium condition. The body is in equilibrium. Is in equilibrium. ठीक है? Because all these 4 forces will try to rotate in an anti-clockwise direction. ठीक है, तो इसी कारण ये इज एन इक्विलिब्रियम. ऑप्शन बी इज करेक्ट. आगे चलते हैं कॉन्फ़िगरेशन आर पे. नाउ ओवर हियर क्या लग रहा है? one force like this, one force like this, so the total force is still equal to 0, and these 2 forces will try to rotate the body in an anti-clockwise direction which is opposite to the direction of the applied moment. So we will be having the total moments equal to 0. So this is also the body is in equilibrium. R भी आपका है equilibrium में. Let us come to S. S. अब S की बात करते हैं, right? Let us suppose on this point the force acting is in this direction, right? F. So definitely because I want this body to be in equilibrium, right? So definitely we will be having an equal force acting in the opposite direction. So this will be creating total force equal to 0. Second condition, due to these two forces we will be having a moment like this, which will be nullifying the applied moment, that is C. So I can say the total moment is equal to 0. So this is also an equilibrium condition. तो इसमें हमारे तीन आपके options are correct, that is B, C and D. B, C and D, all the three options are correct. Clear? All the three options are correct. Understood? Clear hai everyone? Questions were very, question देखो difficult नहीं था, only the logic should be applied. Okay, चलिए, now let's go to the next question on the screen. हाँ, question number 19. This is an interesting question. This is a question asked in 2022. Sorry, 2023. This इस साल का question है शायद. A rope with two massless platform at its two ends passes over a fixed pulley as shown in the figure. The disc with narrow slots and having equal weight of 20 Newton each can be placed. So basically what is happening is just like जैसे gym में होता है ना आपका weights is being attached. So we are having each weight is having a weight of 20 Newton is placed on a platform. Okay. So the number of discs placed on the left hand side is N and number of plates placed on the right hand side is M. Now reading the question further, it is found that for N equal to 5 and M equal to 0, the force F is equal to 200 Newton. Refer to part 1. This is your part number 1. This is your figure number 1. This is your figure number 1. Okay, figure number 1. This is your figure number 2. So they are saying that in figure number 1, it is just sufficient to initiate the upward motion of the left side platform. मतलब ये आपका just ऊपर जाने वाला है. Okay, fine. It is just sufficient enough to initiate the upward motion of the left hand side. If the force F is being removed, then what is the minimum value of M? तो अब हमें second वाला reference देखना है. What should be the minimum value of M such that it will require to prevent the downward motion on the left hand side? ताकि आपका left hand side downward motion ना करे. So try to apply this question. Try to apply the question solution over here. ठीक है, अब देखो सिंपल सा, पहले let us talk about case number 1. Case number 1, when the force F is applied and it is having a magnitude of 200 Newton. It is equal to 200 Newton. Okay, fine. So it is something like this. This is a pulley. We are applying a force F which is equal to 200 Newton. And we are having a disc. Let's suppose we are having a force at T1, right? And that is equal to N into disc. Okay. So here what is happening is the left hand side is sufficient enough to initiate the upward motion of the left hand side. So if we can say this is moving on the upward side. So can we say this is the same problem as that of, let's say assume this as 180 degree because they have not mentioned about the contact. Can we apply the concept of belt and pulley? This is the tension on the tight side, this is the tension on the slack side. So we can say 200 by T1 is, or let us say this is T2, right? 200 by T2. Well, normally we are having a perception that T1 is the tension on the tight side. Okay. So T1 by 200 by T2 is equal to e to the power mu into pi. So from here I can see and what is the value of T2? And they are saying that you are applying 5N, each having a weight of 20. So what is the value of T2? That is equal to 20 into 5, that is 100 Newton. So T2 equal to 100 Newton, so equal to mu pi is equal to 200 by 100, that is equal to 2. Okay, chalo, theek hai. We calculate the e to the power mu pi equal to 2. Coming to the case number 2. Coming to case number 2. In case number 2, what we are doing is we are removing the force F and they are asking you what should be the minimum value of M for of the figure required to prevent the downward motion of the left hand side. But that means still the right hand side is moving in the downward motion. Right hand side abhi bhi aapka downward motion ja raha hai. So basically if I say this is your, let us say this is T3, right, the M side, and this is your N side. Okay, this is your T1. Okay, fine. So they are saying that this is still moving in the downward direction, we can say T3 by T1 is equal to, this is 180 degree, that is e to the power mu into pi. T3 value we don't know, but T1 value we know. T1 is equal to how much? T1 is equal to T2, इसको T2 लिखा ना, T2 is equal to 100, okay, 100, right? So can we say yes, right? कितना है यहाँ पे? We are applying, ठीक है. So what's the value of T3? What is the value? अच्छा, they are sufficient enough to have the downward motion on the left hand side. अच्छा, एक second. If you try to visualize, if the force F is removed, then the minimum value of F of the figure required to prevent the downward motion on the left hand side, ठीक है, तो कितना होगा? So that means this is moving on the upward direction. Just अगर बात करें, that is about to move the upward side. So can we say this is T2 by T1? T2 by T3. This is just about to move on the upward side. So here we can say T2 is 100 divided by T3. This is equal to e to power mu is equal to 2. So this is 50 Newton is equal to T3, and we know that each weight is having a each disc is having a weight of 20 Newton, है ना? 20 Newton. So I can say number of M disc will be equal to 50 divided by 20, that is equal to 2.5. Nearest value will be equal to 3. So answer will be equal to 3. Answer will be equal to, that means if you are applying 3, then we can prevent the downward motion on the left side of the platform. Okay, find just the limiting case. Okay, 2.5 pe it is just about to move, right? Or 3 pe it will be moving in the downward direction. Clear hai? Understood? Question was from the concept of belt and pulley system, belt drive system. Belt drive से ये question था from this year 2023 से, right? Clear hai everyone? Can we go to the next one? Question number 20th. Yes, chaliye next question. This one is also an interesting one. A rigid homogeneous uniform block of mass 1 kg, height 0.4 and width of 0.3 is pinned at one corner and placed upright on a uniform gravitational field. G is equal to 9.81 meter per second square, supported by a roller at the configuration as shown in the figure. There is a roller kept over. This is a roller. Okay, so a short duration impulsive force F producing an impulse of IF is applied at a height of 0.3 meter from the bottom. Assume all joint to be frictionless. What is the minimum value of IF, okay, the impulse, in order to require to topple the block? आपको बताना what is the minimum value of this impulse such that the body will be toppling. बताइए, the body will be toppling. Let us suppose this is point O. Okay, now entire body is rotating about point O. So can we calculate the moment of inertia about point O? So by using simple formulation, IO is equal to 1/3 B square plus H square. 1/3 of B square plus H square, right? So what is this? Your B is 0.3 and 0.4. So 1/3 0.4 square plus 0.3 square. So what is this value? B value is, what's the value of B? B is equal to 0.3 and H is equal to 0.4. 0.4 meter. Solve कीजिए and बताइए what is the value of I0. Once I0 is calculated, after that you can calculate the value of this one. अरे क्या हुआ? 1 second guys. Second. कभी कभार the writing tab is not working sometimes. चल गया. हाँ. So you have to tell me the value of I0. कितना आ रहा है? Anyone who has calculated the value of I0? Plus 0.3 square divided by 3. 0.0883, 0833 है ना, 0.0833. Are we getting this one? Please check. Right? Okay, perfect. Okay, or 1/12 also. We can write it like this. Perfect. Chali. Or we can write it as 1/12. 1/12, approximately 1/12. Okay, chalo. Now we can say if this particular block was kept over here, mass kitna hai? Mass 1 kg hai na? It is 0.0. This is the roller support that we are having. This is the center of gravity. This is the weight W, and we are applying a force, an impulsive force at this point, right? Now after some point of time it will be toppling. ठीक है, वो topple करेगा about 0.0. It will be toppling about 0.0 like this. Okay, this is the center of gravity. This will be the weight W, because this is the minimum value. अगर आपको minimum force लगाना है, that means the center of gravity will be passing through the hinge point, right? So this will be your, let us suppose, the small height h dash. Okay, so can we calculate this h dash height? Anyone? If I try to take this triangle, what is this distance? This height is 0.4. ये आपका 0.4 है, height just center पे होगा, so this is 0.2. Okay, so this is 0.2. What is this distance? That is equal to 0.3. This is 0.3. This is 0.15. So can we calculate OG? This is G dash. OG dash is equal to under root of 0.2 square plus 0.15 square. यहाँ से OG dash आ जाएगा. So H dash will be equal to OG dash minus 0.2. कितना आ रहा है? 0.2 square plus 0.15 square root of this 0.25. So this is 0.05 meter. Okay, fine. So once we calculate the value of H, now we can calculate the concept of energy balance. Energy balance लगाए. The initial, because this will be having an initial omega I, this will be the point, because this is the point where we'll be having the 0 omega, क्योंकि they are asking you what is the value of minimum value of impulse. मतलब एक point पे आके वो रुक जाएगा, जिसमें that we can say this is an impending condition. We are applying a, it is something like this. We are applying a force just like this, and it will be moving and will be stopping at this point. This is the minimum impulse that we need to apply in order to have a toppling motion, right? So इस point पे the omega will be equal to 0. So let us apply the initial kinetic energy will be equal to your potential energy, है ना? So I can say if I apply the energy balance, the initial kinetic, that is I omega O omega square, that is equal to m into g into h dash. Okay, fine. So half into 1/12 into omega I. What is the value of omega I? Initial angular velocity. Have they given the value? अच्छा नहीं देगा, ठीक है. That we can calculate. Mass is given 1 kg. G is 9.81. H dash we are not now calculate 0.05. So from here can we calculate the value of omega I? Omega I will be equal to near about to 9.81 into 0.05 into 24 root of this 3.43 radian per second. Okay, this is the initial angular velocity with which this body will be rotating after the impact. आपने क्या किया? What we have done, we are having this block. Okay, you are applying a impact, small force. ठीक है, तो उस point पे it will be rotating and it will be staying at that position. उसके बाद वापस आ जाएगा because it is about to topple. ठीक है, that means we are talking about the minimum limiting conditions. Okay, so fine. So now we can say the angular impulse will be equal to the change in angular momentum. Change in angular momentum, right? Whatever impulse is being created, this will be responsible to change its angular momentum. So what is angular impulse I into omega? है ना, और I into your 0.3 कितना है, your this one is 0.3. Okay, so it is I final into 0.3 is equal to change in angular momentum, that is your final minus initial, I into initial minus final. Okay, so from here IF into 0.3 is equal to I naught is 1 by 12, omega is 3.43 minus 0. So from here IF value is equal to, what is the moment of inertia at the final position, that we can calculate. Not moment of inertia, this is your this one, impulse. IF is the impulse. Okay, quickly. Because we are applying impulse at this height, yeah, is 0.3, 0.2, applied at a height of 0.3. Okay, we are applying a height at of 0.3. Okay, clear hai? So we can apply a height of 0.3. Let me do one thing, इसको यहाँ पे लिख देते हैं ऐसे. Okay, now clear, right? So 0.953, okay, 0.953 Newton meter, है ना. Impulse will be equal to 0.953 Newton meter. I think anyhow option A is the correct answer. Clear, Sai? Very good. 953 Newton meter. Okay. By 3, 0.953 Newton meter is the correct answer. What we have did, we have initially calculated what is the angular velocity at the initial position. After that, we have calculated what is the impulse after the impact. Okay, impulse की वजह से what change in angular momentum we have observed, that we have calculated over here. Okay, next, last question or second last, second last question, 2023 question. Newton second, right? Newton second, force, 1 second. Newton meter is torque. F into T, impulse is F into T. Chaliye, second last question. A spherical ball of weight 2 kg is dropped from a height of 4.9 meter from a high into an immovable rigid block as shown in the figure. If the collision is perfectly elastic, what is the momentum vector of the ball just after the impact? That means what is the momentum after the impact in vector format they are asking. Okay, you can assume that the extent to gravity is 9.81. Option has been round off to 1 decimal. Okay, so let's try. Options is being round off to 1 decimal. So this is the diagram. So definitely we can say the impact line of impact will be perpendicular to this. Okay, so this will be your line of impact, something like this. Okay, this is the line of impact. This is after collision. This is after collision, initial and final. Okay, and it is squarely visible that it's perfectly elastic and that this part is a rigid block. So it will be having the same velocity after the impact. Hai na? So let us prove it also. What is the value of u1? Let's say this is impacting with the velocity of u1. With what velocity it will be impacting? So u1 will be equal to under root of 2gh, 2 into g into h. So 2 into 9.81 or 9.8. 9.8, h is 4.9. Root of this is exactly equal to 9.8 meter per second. This is the velocity with which it will be impacting. Okay, fine. So can we calculate? Let's say this angle is theta. Let us suppose this angle is theta. Okay, and this angle is also theta, and I think they have given you this angle as 30 degree. This is 30, this is also 30 degree, this is also be equal to 30 degree. We can prove it also, right? If I assume this angle has to be theta, let us suppose, even if I don't know what is this angle, Okay, one thing we can surely say that the velocity along line of impact will be same. So that is u1 cos 30 will be equal to, let's say this is equal to u2 cos theta. Okay, fine, right? And also we can say perpendicular to line of impact, right? This will be equal to u1 sin 30 is equal to u2 sin theta. If you compare both the equations, equation 1 and equation 2, can we say u1 is equal to u2 is equal to 9.81 meter per second, right? That's it. Now after the collision, what is happening is, this is the situation, this is u2, this is 30 degree. Okay, and we have to calculate the momentum vector after the impact. So can we say this is equal to, mass is equal to 2 kg, right? So it will be equal to m1 or mu2 along the x direction. This is x, this is y. X direction mein which velocity will be responsible? U sin theta, है ना? U sin 30 I cap plus m into u2. This one will be equal to this one, right? This one. What will be this velocity? Yes. What will be this this velocity? Cos 60. Very good. 17 I cap plus 9.8 J cap. Perfect. Anyone else who has calculated this? Dekho, just only thing you have to do the calculations. Dekho, this is 30, this is also 30, so this is your 60 degree. The total angle is 60 degree. And this total angle is 60 degree. Chalo, let us do it like this. The total angle is 60 degree. Okay, so I can say along the horizontal direction will be equal to m u2 sin 60 degree I cap plus m u2 cos 60 degree J cap. This is the final momentum. Okay, what is mass? Mass is equal to 2 kg. So this is 2 into 9.81 cos 60 is root 3 by 2 I cap plus 2 into 9.81 cos 60 is your 1 by 2. Okay, so this is equal to 2. This is 9.8 root 3 I cap plus 9.8 J cap. This is the momentum vector. So we are getting option C. What is this value? This is somewhere around 17 I cap plus 9.8 J cap, because they have said that you have to round off to the 1 decimal. You have to round off to 1 decimal. So this is the nearest value. Option C is the correct answer. Okay, option C is the final correct answer that we are getting. Right? Fine. Chale, last question on the screen. Question number 22nd. This is a very easy question from the area moment of inertia. Very good. Area moment of inertia they are asking you. Now, if you try to visualize, if I try to make it this into a simple concept, like let's suppose this is a rectangle. Okay, this is a rectangle. And if I try to remove the moment of inertia of the triangular portion, can we calculate the half value? And once we calculate the half value, problem is solved. Multiplied by 2, get the answer. Right? You try to calculate in a simple aspect that you calculate for a rectangle, right? For rectangle, we know what is the value, right? So the moment of inertia of a rectangle is the moment of inertia of a rectangle, right? You have to calculate in the y-axis direction, in y-axis. Okay, that is this is your rectangle. having a dimension of, let's say this is O, this is A, this is B, this is C, right? This is your y axis, this is x axis. Okay, the dimension is 3 and this dimension is 3 and this base is 12 meter. Can you tell me what is the moment of inertia using parallel axis theorem? Okay, one third of this. So 1/3 of mr square. Your width is 3 into 12 square. So this is 12 square. 12 cube. 12 cube meter 4. If I talk about the rectangle portion, the triangle portion, the triangle was something like this. This is O, this is C, this is B, right? And this height is this one. Let's say this is O, A, B, this is C, right? And if I say this is D, so we are having D, B, C. This height is 1.5, this length is 12 meter. Can we calculate the moment of inertia of a triangle? The moment of inertia of this triangle along CD, that is y axis. This is along OC, that is y axis. Okay. What will this? Your 1/12, 1/12 of 1.5 into 12 cube. So this is equal to how much? This will be equal to 8. 12 cube by 8. Okay. Yes. 150 by 120, that is 840. So we can say the moment of inertia of this portion OABD is equal to the moment of inertia of the triangular part minus the moment of inertia of the rectangle. Rectangle minus triangle. Rectangle is 12 cube minus 12 cube by 8. This is equal to 7 by 8 into 12 cube. If I want to get the moment of inertia of the entire section, that is equal to 2 times 7 by 8 into 10 to the power cube. This is 7 by 4 into 12 cube. Nearest value 7 by 4 into 12 cube. 12 cube into 7 divided by 4. 3024 meter power 4. Okay, so 3024 is the correct answer. 3024 meter square is a meter to power 4 is the correct answer. So these were the 22 questions from the last 4 years that is being asked from the GATE examinations, right? Okay. 3018 or 24? Ashay? 18 or 24? Please check. I think we should be getting 3024. All right. So these were the questions from the 2020 to 2023. All the questions from all the sets we have covered. I'll be sharing the PDF of this session on my Telegram channel that you are seeing on the screen, where you can download it for your future reference. And this is it from my side. I hope you all enjoyed, right? So now let's meet in our app classes, because it was scheduled to be at 8 o'clock, but okay, let's quickly start off that also, right? So let's meet in our app and we'll be talking about the questions from the friction topic. Okay, in 2 or 3 minutes we'll be coming up live. Okay, thank you. Bye bye. Take care, stay safe, and enjoy your day with BYJU'S exam. Thank you.